Hello everybody and welcome to exercise 3. This problem is asking us to solve a differential equation, and remember that the goal in this type of a problem is we're looking for a function that satisfies this formula. So we're looking for a function such that its derivative dy dx is equal to 6y squared times sine of x squared. All right, and we've really just talked about one technique for solving a differential equation, and that's separation of variables. And this is a nice opportunity just to review that process. So generally what you do is to start off by multiplying both sides by dx. Remember, the goal is to separate the variables here. Okay, so multiplying by dx is the first step to doing that. And we'd like to get all the y's on the left and all the x's on the right. Notice that if we divide both sides by y squared, that's going to get the y squared that's over on the right-hand side over to the left for us. Okay, so we're going to get dy over y squared is equal to 6x times sine of x squared dx. Okay, what do we do at this point? Okay, well again, the goal is to solve for y. We'd like a formula for the function y. Okay, and once you've separated the variables, it puts us in a situation where we can integrate both sides. Okay, so we've got two integrals to do. And over on the left, notice that we can rewrite that as just y to the negative 2 dy. Okay, and on the right, I'm just going to rewrite that for now. Okay, we'll do these integrals one at a time. Over on the left, y to the negative 2, we can find an antiderivative for that just using the power rule. That's going to give us y to the negative 1 over negative 1. And what about on the right-hand side? Well, you might notice there that we're kind of set up nicely to do a U-substitution. If we let u be x squared, du is 2x dx, and we can go ahead and divide over and get du over 2x equals dx. All right, so filling in the pieces, let's see, we're going to get a 6x times sine of u, and dx we can see from our work is du over 2x. Okay, there's a little bit of cancellation that happens. So those x's are going to go away, and then we've got a 6 over a 2, which is really a 3. Okay, so let's do a couple of things here. The y to the negative 1 over negative 1 on the left, let's rewrite that as negative 1 over y. Okay, and then over on the right, let's do our simplification. Take that 3 out, and what's left to integrate is just sine of u. Okay, and let's see. If we take an antiderivative of sine of u, we are going to get negative cosine of u. Okay, and then finally go ahead and fill in what that u is equal to. Okay, looking at our work, that's just x squared. Okay, and we're done with the integration part. Okay, so the question is, what's left to do here? Well, remember, again, the goal is to find the function y. We'd like y as a function of x. Okay, so if it's possible, we'd like to isolate the y. Okay, and there are different ways to do this, but in our situation, maybe the easiest thing to do would be to take the reciprocal of both sides. Okay, so negative 1 over y, if we take the reciprocal, that's going to give us negative y over 1. Okay, and we're going to do the same thing on the right-hand side, take the reciprocal of that. Okay, which is going to look like that. And let's see, what's left to do here? Probably just multiply both sides by a negative 1. Okay, because that's going to turn the minus y that's in the left into just a y, and so we're going to get a final answer that looks like negative 1 over negative 3 cosine of x squared plus c. Okay. Okay, and I want to just make a remark at the end of this. There are different ways that you could write your answer. If you look at my written solutions, you might notice that I wrote it like this, 1 over 3 cosine of x squared minus c. that's actually equivalent to the answer that we have here, because you could take the answer to the left and multiply the top and the bottom by -1, okay, which would result in an equivalent fraction, and that's going to give you this answer. Okay, so it just illustrates that you might sometimes have your answer in a little bit different of a form than mine, and it can still be correct. Okay, and I believe we're done with this problem.